Example 2.4, we have a piecewise defined function. It's broken up across a couple of different points. Let's show that this function is not continuous at -5, -1, and at 3. So in order to show that a function is not continuous, we just need to show that the definition of continuity is not met. Right, we need to show that the limit as x approaches some point A does not equal the function at A. And this could be true for a lot of different reasons. The function could not exist at A, the limit could not exist at A, or they could both exist, but they're just not equal to each other. Right? Any of these reasons would give us a discontinuity. So let's look at -5 first. The limit as x approaches -5. So let's think about the limit existing. If I approach from the left, on the left side of -5, I'm the function x. And via direct substitution, x approaches the value of -5 as x approaches -5. All right, let's look at the right-hand side. As I approach -5 from the right, I don't know why it looks like that. That should read -5 less than or equal to x less than -1. So on the right side of -5, I look like -1 over x plus 2. Via direct substitution, you get -1 over -5 plus 1. That's -1 over -4. That's 1/4. So on the left-hand side, you approach -5. On the right-hand side, you approach 1/4. The limit does not exist. Therefore, there's no way that your function is continuous. All right, the next point where I need to show discontinuity is at -1. Let's see if the limit exists. As you approach -1 from the left, on the left side of -1, so again, that should read -5 less than or equal to x less than -1. So on the left side of -1, you are the -1 over x plus 1 function. And direct substitution, if you plug in -1 there, you get -1 over -1 plus 1. That gives you a -1 over 0. That is not well defined. We have a vertical asymptote there. So this is equal to, well, it's not really equal to. It approaches -infinity. But this is not a real number. This does not exist. So the limit, the one-sided limit doesn't exist. There's no chance of the actual limit existing. Therefore, this function has to be discontinuous at -1. And our third point of discontinuity at 3. So let's look at x going to 3 from the left. On the left side of 3, you are 1 over x plus 1. Via direct substitution, you get 1 over 4. If you approach 3 from the right, so on the right side of 3, you are x minus 2.75. Direct substitution, 3 minus 2.75 is 0.25 or 1/4. So the left hand and the right hand side give you the same limit. They approach the same value. So really we have sort of this situation going on where that y value is 1/4. The only question is, does that equal your function value? So is your function value also 1/4 at that point? Can you draw this without picking up your pencil? So the question is, does f of 3 equal 1/4? Going up to your definition, when x is equal to 3, your function returns a value of 5. So 1/4 is not equal to 5. Even though your limit exists there, right? You approach the value 1/4, your actual function value is up here at 5. Therefore, it's discontinuous there as well.